If you will turn to page 460, it says, Activity 3.2, practice solving equations. In this activity, you will use double number lines to solve equations. So we did this in a different activity. This one has just a little bit more of rational numbers as opposed to just positives and negatives. It says model each equation on the number line given. So this one I can totally see how this might confuse you. So as a reminder, I'm just going to put, I'll put 0 here, okay? And then I'm going to put way over here, I'm going to put half x plus 5. And remember, generally our goal is to find what x equals, okay? And so I'm going to put this here so we can kind of talk about it, and we can show you, I'm going to show you a different way to solve it. Okay, so half x plus 5 is equal to 15. So remember, one of the first things we do, we get rid of that plus or minus first, that easy shift. So I'm going to get rid of plus 5, so that means I have to move it backwards 5, and again, I'm just going to make up this number here, but we're going to not make up the number, but make up the placement, half x. So I move it backwards 5. 1, 2, 3, 4, 5. Okay, half x. So when I move this one back 5, it becomes 10. And guys, again, I don't know how properly spaced this is. So what we did was we did minus 5, minus 5. So I still have half x equals 10. I'm just transferring this to the equation. Okay. Now we want x. Okay, so I want you to think, and again, this is not proper placement, but I want to get to x. So I can tell you x is going to be this direction. Okay, so I want you to think on a number line, 0, half, 1. Okay, so 1, I'm going to say we have half, and then we would jump again to 1x. So x is actually going to be here. Notice I did not equally space this. It is not spaced correct. It is not spaced correct. Okay, so I'm doubling this to get to the x. So that means I'm going to double this right here, and that would be 20. Okay, so our answer here is going to be 20. Now, how does that translate here? Well, I want to get rid of the half. So to get rid of the half, what you really do, I usually tell the kids, remember, when you divide a fraction, this is multiply. To get rid of multiply, you divide. When I divide a fraction, I do keep, change, flip. That's basically what I'm doing. 2 over 1, which is the same as 2. I do that because that will cross. Okay, so that will be 20. So that one's a little more confusing. They normally don't give you a fraction in front, but they're actually real easy. Just whatever the denominator is, you multiply both sides by that. Okay. Over here, we'll start with the same thing. I'm just going to put 0 here. And over here, I'm going to put 52.5. And down here is t minus 3.1. Okay. I probably should have moved it over the other way a little bit. That's okay. So in this case, I don't want minus 3.1. I want to get rid of it. So that means I'm going to shift this down some this way to the right. Or maybe I could say shift it up. I'm moving it 3.1 to get rid of that. Okay. So I'm going to add 3.1. I have to add 3.1 here. Okay. So when I add 3.1, 5 plus 1 is 6. 2 plus 3 is 5. And 5. Okay. Just like here. Do the same thing to both sides. 6, 5, 5. And then t is by itself. Okay, I don't have to do any multiply. I don't have to do any divide. So we're going to move to page 461. Okay. And do the same thing. I'm just going to put my 0 here. Then somewhere over here, again, not spaced right, I'm just putting it, is 4b plus 4, which is equivalent to 20. Remember, these are the same, so they go top and bottom. So 4b plus 4 equals 20. Okay, so I want to get rid of that plus 4, so I'm going to shift it to the left sum by 4. I'm going to subtract 4. So then I get 4b. When I subtract 4 here, I get 16. That's what's happening on my equation. We do the same thing. Okay. Okay. Now I want 1b, so I have to divide this into 4 parts. Okay. See if I can do this kind of equally. 3b, 2b, 1b, or just b. So guys, I'm just dividing by 4. Like 4 divided by 4 is 1. 16 divided by 4 is 4. Okay. We're just kind of showing it both ways, with and without a model. Okay. Okay, so on here, again, say m plus 4.5. I messed that up. Try again. I'm going to put 0, sorry, and then over here, I'm going to put m plus 4.5 is equal to negative 10. So as you can tell, this is not correct because the negative 10 should be to the left, right? So 0, and we'll put negative 10 here, okay? And that's okay. This is why we show math in pencil, so if we make a mistake, we can fix it, okay? So negative 10, we're going to put below that m plus 4.5. So if I don't want plus 4.5, I have to go to the left because that's going to make it minus. So I'm minusing 4.5. When I get rid of that plus 4.5, it becomes m here. So as you can tell, this is a good example. This is a good example right here of same sum add. We're adding to the left, okay? It's getting more negative, okay? We already solved this one. And now what we're going to do is we are on page 462. And we're going to kind of use the number line as we solve this, okay? So this says negative 6x minus 8 equals positive 10, okay? So I'm going to look at my number line here. Here's our starting point. It equals 10. That's at point A, okay? So step B is what they did next. So what they did was they were saying, oh, well, it's minus 8. Remember, we want to get rid of that first, so they shifted it to the right because we are adding 8. (10 plus 8 is 18. And look, that's what we have, okay? Now, remember, we've talked about a reflection before in here. So this is negative 6x. It's on the wrong side. I'm going to move it over here, which means basically I'm multiplying by negative 1. I am multiplying by negative 1 to make it positive, or in this case, I am going to divide by negative 6 to make it a positive. I'm sorry, to make the x a positive. I'm not saying that correctly. I'm going to divide these by negative 6 to make the x a positive. So what they did is they basically reflected this. Okay, they reflected this. It's right here. And then they would break this up 6 times, right? Because at 6, I would have to like 5x, 4x, 3x, 2x, 1x. So we're dividing by 6. So negative 18 divided by 6, and I would get negative 3. You can tell I'm on that negative side. So that can be kind of confusing here. Okay, so one more time. Here's where we start. We don't want the negative 8, so we do plus 8. That puts us here and here. I added 8 here. Then we reflected it over here. So if it was, we did the, not really the opposite, but if it's negative 6 multiplied by negative 1, I'm going to get positive 6. Multiply that one by negative 1, I get a negative 18. Remember, we're doing that maintain equality. Then once they do that, then they are dividing by 6. So I'm kind of doing it in one step. I did divide by negative 6, divide by negative 6. They are kind of doing times a negative 1, then dividing by 6.